Welcome, my friends! In this video, I will be graphing transformations of cosecant and secant. I have the untransformed versions of cosecant and secant on the screen now. To graph cosecant or secant, I first graph the corresponding reciprocal function of either sine or cosine in a dotted line, and then I graph either cosecant or secant on top of it. Anytime that you have a maximum or a minimum on sine, you will have a shared point on cosecant. The same is true for secant. Anytime that you have a maximum or a minimum on cosine, you will have a shared point on secant. Anytime that sine is equal to 0, you will have a vertical asymptote on the graph of cosecant. Anytime that cosine is 0, you will have a vertical asymptote on the graph of secant. Let's try some examples. Say we are asked to graph y is equal to 2 times the secant of 3x. We will start this by graphing y equals 2 times cosine of 3x, because cosine is the reciprocal of secant. You should hopefully know that the absolute value of the number multiplying the cosine function is what we call the amplitude. This cosine function will oscillate between 2 and negative 2. This function also has a change in period, indicated by the value multiplying x. In general, we call the value that multiplies x b. You can find the new period by taking 2 pi and dividing by b. So that means for this cosine function, the period is 2 pi over 3. We will have important points on the graph of y equals 2 times the cosine of 3x at every quarter of the period. I've been calling this the increment. In our case, 2 pi over 3 times 1 quarter, or 1 over 4, is equal to 2 pi over 12, which reduces 2 pi over 6. That means we will have an important point on the graph of y equals 2 times the cosine of 3x at every pi over 6 radians. Let's graph y equals 2 times the cosine of 3x. We will then use that graph to graph y equals 2 times secant of 3x. We know that typically a cosine function starts at its maximum and then decreases from there. In this case, since our amplitude is 2, the maximum will be at 2, so we start our graph at 0, 2. My general strategy for graphing secant or cosecant is to include 3 vertical asymptotes on the graph. That means if I'm graphing cosine first, I must include 3 zeros on the graph, because the zeros of cosine correspond to vertical asymptotes for secant. A positive cosine function starts at its maximum and then decreases to 0 at the next increment. Our next increment is pi over 6, so we will have the point pi over 6, 0 on our graph. That will be the first of 3 zeros we want to graph before graphing secant. Next, cosine will decrease to its minimum, which will be negative 2 in our case, at the next increment, which will be at 2 pi over 6. Then we will increase back to another 0 at 3 pi over 6. That's 2 out of 3. We will increase back to our maximum of 2 at 4 pi over 6, and then we will have our final 0 at 5 pi over 6. Like I've discussed in other videos, you can reduce these increments if you'd like to, but I prefer to leave them all with the same denominator. If we connect the dots in a dotted line, we will have the graph of y equals 2 times the cosine of 3x. I use a dotted line here because this really isn't our goal. We would like to graph y equals 2 times the secant of 3x, but we are using the graph of y equals 2 times the cosine of 3x to help guide us. The next thing I do is draw a vertical asymptote at any time the cosine function has a 0. So that's at pi over 6, 3 pi over 6, and 5 pi over 6. Then I know that cosine and secant have a shared point at any of the maximums or minimums, so that would be here, here, and here. All of that information should be enough for you to finish drawing the function. Here is what the graph of y equals 2 times the secant of 3x looks like. Let's try another problem. We have y equals negative 3 halves times cosecant of 1/3 x. Just like in the last problem, we will start by graphing the corresponding reciprocal function, which is y equals negative 3 halves times sine of 1/3 x. Let's start by finding the period. The period is always 2 pi divided by the coefficient multiplying x. So in this case, we have 2 pi over b equals 2 pi over 1/3. We can reciprocate and multiply so that we have 2 pi times 3 over 1, which is equal to 6 pi. We know we will have important points on the graph at every quarter of the period. 1 quarter of 6 pi is 6 pi over 4, which reduces to 3 pi over 2. We will have an important point on the graph of negative 3 halves sine of 1/3 x at every 3 pi over 2 radians. Let's start to graph the function. Notice that we have a negative sine function. A positive sine function would start at 0, 0 and then increase from there. A negative sine function, on the other hand, would start at 0, 0 and then decrease from there. Either way, our first point is going to be 0, 0. Again, since we have a negative sine function, we are going to decrease to our minimum at the next increment. Our increment is 3 pi over 2, so at 3 pi over 2, we will be at our minimum of negative 3 over 2, since we have the coefficient of negative 3 over 2 on our function. Then at the next increment, we will increase back to a 0 at 6 pi over 2. We will continue to increase to our maximum of 3 halves at 9 pi over 2. Going one more increment, we will be back at 0 at 12 pi over 2. At this point, we have graphed 3 zeros, one at 0, one at 6 pi over 2, and one at 12 pi over 2. These will correspond to the vertical asymptotes when we graph cosecant. Let's connect the dots in a dotted line that represent y equals negative 3 halves sine of 1/3 x. Next, anytime that you have a 0, draw a vertical asymptote, which will be at 0, 6 pi over 2, and 12 pi over 2. Then we know that any of the maximums or minimums on the sine function will be a shared point on cosecant. So at 3 pi over 2, negative 3 halves, and 9 pi over 2, 3 halves. This should be enough information to draw your function. Here is what the graph of y equals negative 3 halves cosecant of 1/3 x looks like. Again, note that the graph is only the solid line, not the dotted line. The dotted line represents y equals negative 3 halves sine of 1/3 x, which we only graph for convenience. Let's try this one. We are asked to graph y equals 2 times the cosecant of x plus 2 pi. Just like last time, let's start by graphing the corresponding reciprocal function, which is y equals 2 times sine of x plus 2 pi. The period is 2 pi divided by b, but we don't have a value for b multiplying x, so the period is just going to be 2 pi. Our increment is 1/4 of that, which is just pi over 2. Notice that we also have a phase shift, indicated by the value added on the inside of the function. This will be a shift of 2 pi units to the left. Let's graph the function. Typically, a sine function would start at 0, 0, but since we are shifted 2 pi units to the left, I will instead start at negative 2 pi, 0. Instead of labeling this as negative 2 pi, I'm going to label this as negative 4 pi over 2 to match our increment. From the beginning of its period, sine typically increases if we have a positive sine function, so we will increase to our maximum of 2 at the next increment, which will be at negative 3 pi over 2. Then we will come back to another 0 at negative 2 pi over 2. That's 2 out of the 3 zeros we would like to graph. At the next increment of negative pi over 2, we will be down to negative 2, and finally at 0, we will be at 0. If we connect the dots, we will have the graph of y equals 2 times the sine of x plus 2 pi. Now something that you could have noticed if you were clever is that by adding 2 pi to the inside of the sine function does not actually change the function. The period of sine is 2 pi, so if you just add 2 pi to the argument, that's not going to change the function. So this would be the exact same function as y equals 2 times the sine of x, without the 2 pi added. The next step in graphing cosecant is to graph a vertical asymptote at any time that you have a 0 on sine. So that would be at negative 4 pi over 2, negative 2 pi over 2, and at 0. From here, we know that any of the maximums or minimums on sine will be a shared point on cosecant. That should be enough information for you to draw the graph. Here is the graph of y equals 2 times the cosecant of x plus 2 pi. Let's try one more problem. We are asked to graph y equals negative 3 times secant of 3x minus pi over 2. Let's start by graphing the corresponding reciprocal function, which is y equals negative 3 times the cosine of 3x minus pi over 2. Remember that when you have both a change in period, indicated by a value multiplying x, and a phase shift, indicated by a number that is either added or subtracted on the inside of the argument, you must factor out the value on x to correctly identify the phase shift. So we will have negative 3 times the cosine of 3 times x minus something. Now the way that I think about this is we are dividing out 3. So if we just take pi over 2 and we divide by 3, we would get pi over 6. So pi over 6 is the number that we need inside the parentheses. The period is 2 pi divided by b, or 2 pi divided by 3, either the value here or the value that you divided out. So our period is 2 pi over 3. The increment to which we will have important key points is 1/4 of the period. 2 pi over 3 multiplied by 1 over 4 is the same thing as 2 pi over 12, which is the same thing as pi over 6. Also note that we have a phase shift of pi over 6 units to the right. Let's graph our function. Starting by graphing cosine, we know that the cosine function typically starts at a maximum and decreases from there. Since we have a negative cosine function, we will instead start at a minimum and then increase from there. But we don't start at 0 because we have a phase shift of pi over 6 units to the right. So instead of starting at 0, -3, we will actually start at pi over 6, -3. From there, the cosine function will increase to a 0 at the next increment. The increment is pi over 6, so adding pi over 6 to pi over 6 will give us 2 pi over 6. This is our first of 3 zeros we would like. Next, this function will increase to its maximum at the next increment of 3 pi over 6. Then we will decrease back to another 0 at 4 pi over 6. We can increment one time to the left by subtracting pi over 6 to find one more point, which will be our last 0, at 0. At this point, we have 3 zeros, so we can graph y is equal to -3 times the cosine of 3 times x minus pi over 6 by connecting the dots. If we'd like to graph secant, we can draw vertical asymptotes at any time we have a 0 on cosine, which will be at 0, 2 pi over 6, and 4 pi over 6. Then we know that secant and cosine share points at either the maximum or minimum of cosine. We can use this information to finish our graph. This is the graph of y equals -3 times the secant of 3x minus pi over 2. Alright my friends, that finishes this video graphing transformations of secant and cosecant.